Now, Sarah, you have one that, if you call it out in a moment. Okay, Sarah, so what's that one as an example? Hang on, let me try and fix the colour. There. dy dx equals
3 over brackets y plus 1 over e.
Good, okay. So now, Hind and Precious, come on, are we focusing? And Joseph. I don't know if you were talking, but it just looked like maybe you were.
How is it that for the end of the math and
Don't know. I just sense trouble over in that direction. It doesn't feel right over there. There's a disturbance in the force, and I don't know. Alright, okay. The left side is the y side, and the right side is the x side. So I need to bring the y plus 1 down to the left, and I need to bring the dx to the right. I do not like the ex in the denominator. I shall put it in the numerator as a minus x power. Integrating both sides. The left is a formula in the formula book. It is log y plus 1.
sorry, where's the 3?
I lost it. And
It's with the y plus 1.
oh, the 3 is just on the y.
No,
It's 3y plus 1. Sorry, okay.
No, it's I don't understand where you put the 3 y. Like when you move the y plus 1.
Yeah.
Don't you put the 3 with it?
No.
Why?
Why would I? So? So, I mean,
So?
I can bring just one piece along. I don't have to bring them all along. Yeah. Don't look confused.
That's not maths.
Yes, it is. Look.
What are the rules that we learned?
Look. Okay. 8 is 4 times 2. I can bring one of the pieces to the other side. I don't have to bring them all. Okay. Now, on the right, this is a rule, and it will be in the formula book also. It will be minus 3 e to the minus x plus c. We cancel a log by using an e, so I get y plus 1 equals e to the power of minus 3 e to the minus x plus c, and I can take this 1 to the other side. And that's the answer then. No, this is from somewhere else. It's not in the worksheet. So just take note of it as another example.
This is ODE.
Yeah. Number 7, sure, yeah. Can I scroll down now? Yes? Okay. So, Fian, can you call out number 7 then? Yeah. Y bracket 1 minus y. Okay. Over. No, over, just like this. Okay. The left side is the y side. Right side, the x side. So on the left, we get 1 over y 1 minus y dy equals dx. Oh, by the way, you can write the dy here or in the numerator. It's not really important. But I wrote it this way to make a point. How do I integrate this? What do I do? So throw Stephen a bone. Log? No, not log.
Yes, it should be log y.
True. If you expand, you get 1 over minus y squared plus y dy equals dx. So now what? Cast your mind back when we had quadratics in the denominator. What are the things we could do? There are substitutions, are there not? There is completing the square, is there not? And something else? Shall we say perhaps proper partial fractions? And it was the hope that you would recognize that, because that's why they didn't multiply out the top. So that you can see that this is one of these a over y plus b over 1 minus y dy equals dx. Now, we know how to find the a and the b. And when you go through the process of finding the a and the b, you will get, I think, a is 1, and I think you'll also get b is 1. Minus 1. Let me double check this. They'll multiply 1 minus y plus... No, yeah, it'll be like this. The formula book tells you that this is log y, and the formula book also tells you that because the minus here, this will be minus log 1 minus y. By the way, if you don't have the formula book, please print it out. It's very helpful. All the rules are in there. Equals x plus c. When you subtract logs, you divide. Y over 1 minus y equals x plus c. To cancel a log, we use an e. Cancel e like this. Multiplying, we get y equals 1 minus y e to the x plus c. So we get y equals e to the x plus c minus y e to the x plus c. Bringing the y's to the left and the x's to the right, we get y plus y ex plus c equals ex plus c. The y's are common on the left. Y 1 plus ex plus c equals ex plus c. And then finally dividing. Y equals ex plus c all over 1 plus ex plus c. More zoom out?
Yeah.
Can you still read that? Yeah. All right. Yeah.
Can you zoom where they can
Is that the last one?
Yeah.
Okay. I saw a question almost identical to this in last year's paper.
Section 8.
I don't know. I don't remember. Although, if this was in the exam, I do suspect them to break this question up into two parts. Part A, to find the partial fraction, and then part B to solve. So you would have been prompted to find the partial fraction to begin with. We got that now?
Yes.
So number 11. So 11 part 1. By use of implicit differentiation and the quotient rule, simplify the derivative of y over x. Is that right? Was that not the last one on it? You said it was the last one, Hassan.
No, the last question, first part, 11.
Ah, not the very last question. No. So what's the last part one then? Let me write it down here.
dy over dx
dy over dx
minus 2xy over x squared plus 1
yeah.
equals 0.
Alright, so if it equals 0, then we bring that to the other side and we get them equal like that. Cross multiplying, we get dy over y equals 2x over x squared plus 1 dx. Yes? Here we have to say u equals x squared plus 1. It's one of these problems where the derivative of the denominator is equal to the numerator. So we have a shortcut rule here. We know the answer to this will be log x squared plus 1. This will be log y plus c. Put in the e's to cancel, and you'll basically end up with y equals x squared plus 1 times e power c. Yeah, because originally what was here was e log. Yeah. I skipped a couple of steps of simplifying, but you end up with that in the end. When you put e on both sides.
The answer of the event is e to the power of 10 minus 1x. That is it.
Done. Did you read it out right to me? Did I write it down right?
Yes.
Then I must have typed something wrong. Yeah. The answer's wrong then. It can't be that. I must have typed in an extra x or something. I don't think the x should be there in the question. What's on? No, cannot. We can only bring constants out. Where is it? Yeah, okay. There shouldn't be an x in the numerator. So I'll do it again, but without any x in the numerator. So here's the question again. So dy dx minus 2y
Over x squared plus 1.
Yeah, I actually think the question should have been typed as just y here, not the 2x, okay? So anyways, I'll do this one. Okay. So take this to the other side again, and you get equals, and then divide, and you get this one. And then integrate both sides. I think it's going to be okay. Now here is log y, and then here is from the formula book, tan inverse x, and then you put e on both sides. So you get y equals e tan inverse x plus c, and then the c will end up being 0 with whatever point I give you. So just remove the 2x from the question 11 numerator. Which one? The very last one? That's the one I thought I was about to do. Yes, okay. So the very last question says, simplify the derivative of y over x by use of implicit differentiation and the quotient rule. Right? Do you have your questions there, Curdy? Where are your questions? No. Where's your worksheet? Might be a good idea to take it out. All right, so the last question here is, what's wrong? Huh?
This is verify y equals e minus
This is, oh my goodness, why don't you? When you said the very last one, I thought you had the very last one. No, this is just fixed on and obtained. It couldn't possibly be a question. Why would it be a question on the last question sheet? You want this one, is it? No. You can do it. Did you try to do it? For real? So what rule do you need here when you differentiate? The product rule. And then the derivative again? And you put them all into this, it will not be 0. So? Right, it's not. Okay, well let's check it then. So it's e minus x cos x. You all understand what I mean when I say the last question? Because twice now I said the last question and you went, yes, the last question of the middle. I don't actually think some of you speak English. I think it's been all a trick all this time. It's like one of those illusions. You're like, yeah, speaking English. Well, no, you're actually not. Okay, so the second last one. I tell you y equals e to the power of minus x cos x. Yes? Okay, so let me actually just get rid of the y piece there. So there's y. And there's the derivative of y using the product rule. And then there's the second derivative using the product rule again on this one here. So we need to verify that the second derivative plus the first derivative minus the y equals 0. So I'm sorry if this is not equal to 0, but let's see what we get. No, it's not. Okay. So you're absolutely right. It won't equal 0 then.
This is question 5, right?
This is the second last question.
No, I know. Wait, I mean the exam. It's question 5, right?
It is question 1 or 5. Mostly 5. Sometimes it sneaks into the end of number 1. Disgraceful. This will not do at all. Guys, you do know, like, you can still use derive to help you with your studies. Like, it's a tool.
Exam.
No, but if you need to check if you're doing something right, you know, derive will not give you the wrong answer. So if you feel confident that you did it right, you can confirm that you did. You know, that's why you were shown derive, to help you with your studies. It wasn't just for fun. Because sometimes students still use derive when they go on to university to help them with their maths homework and their maths studying and their maths revision. And their medicine studying and revision too. Yes.
There's no medicine.
You will learn the diagnostic function and the prescribed medication function next year. Okay. What I'll do is you can just change that question theme to write plus plus plus, so they're all plus. Okay. So second derivative plus first derivative plus y, and instead of making it equal 0, it should equal this. Okay, do you want to change it on the worksheet then? So I need to delete that 2x thingy, go away, and then change the last one. e to the power of minus x sine x. Okay, now we'll start the next lesson then. So like I said, this next lesson is very, very important for your assignment. This is recording, yeah? Yes. No, well, Newton-Raphson isn't really in the assignment. I mean, you could use it. I don't want to tell you too much. Okay. So what we're going to look at now is practical problems. So to help you get started, I'm going to give you some vocabulary. When the question says rate of change, that means the time derivative. And proportional, rather than, that's this symbol here. Now, proportional is one of these things that you would know from chemistry and you would know from physics. So if I say A and B are proportional, what that means is if you double A, then B likewise will double. Or if you half A, B likewise will be halved. So that's what the word proportional means. But mathematically, what can you do with proportional? And this is what it is. If I tell you A is proportional to B, that can be written as an equation as follows. You can say A is equal to some constant, which you do not know, multiply B. And together with these two pieces of information, you pretty much can write these problems and do these problems. So I'll give you an example from biology then. Okay, can I scroll down? Yeah. So often you have from biology the rate of change, or in other words, the growth of bacteria cells or virus or whatever. I'll just write cells. The rate of change of the number of cells in a, I'm not going to give you all the correct vocabulary, I'm going to be lazy, but We don't say in a dish, we say in a petri dish. Do you know this? Petri dish? Yeah. So I'm just going to say the rate of change or growth of the number of cells in a dish is proportional to how many cells are in the dish. Also, you have this stuff from chemistry as well. For example, in chemistry, the reaction rate of a reactant is proportional to the level of concentration of the reactant. Also, what's the name of that law in chemistry? That the reaction rate is proportional to the concentration of the substance, the reactant. What's it called? No. What is it? I'm sorry. What? No. Make it sound more dull. It's a no. Have you heard the word first order law? Wait, hang on. Maybe you haven't. But there seemed to be a strong reaction when I just said first order law. There was lots of yes, no.
It was just Morana.
It was just Morana.
Yes.
Maybe Nigeria.
Right. Okay.
Not here.
Right. Tell me if you've done this law in chemistry, that the reaction rate of a substance is proportional to the concentration squared. No. Well, this is called the second order reaction rate law. If I say first order reaction rate law, that's none happening, right? Because I remember last week I saw Lorraine had the law written up on the board, and she had it like this, something like this here, and then proportional here.
No.
She had something like this equals, and then here reaction rate.
That's what I said.
That was what? Okay. Whatever. Anyways, last year the maths assignment was about reaction rate. This year it is not. But anyways, here's the biology example. The rate of change of growth of the number of cells in a dish is proportional to how many cells are in the dish. In other words, the more cells that are in the dish, the quicker it will be growing, which makes sense because the population is bigger, so it's more able to reproduce, divide, and grow even more. Okay? So we have to write this as an equation. So we need to choose a letter to represent how many cells are in the dish. So what letter will we choose for that? All right. I was going to go with N, but C will be fine. So that's how many cells are in the dish. So let's read the question again. The rate of change. So what's the rate of change? That's the derivative. Is proportional to how many cells are in the dish. Which is what letter? C. Yeah, does that make sense if you read it? Now, how do you drop a proportional symbol? You drop it by adding in a constant. So now this is the equation which you need to solve. So you have dc over c equals k dt. Integrate. What do I get on the left? No. Log c equals k t. Yes? Now, unfortunately, because you chose the letter C, do not confuse it with the constant C at the end here, which I'll write as a small c. What? 1 kt is kt, yes? So suppose this was dx. What is the antiderivative of a constant? Like, what is the antiderivative of 5? Wait, what? Can I move on or not? Right. How do I cancel the log? With an e. So now I get c equals ekt plus a small c. Now please note, it's fine if you leave it like this, but the normal convention is to do the following. You split this e into two pieces, an ec and an ekt. And the reason for that is c, it is a constant. True? Yes. And e to the power of a constant. This is also a constant. True? So it is normal just to rewrite this as c equals to some constant multiply some constant power t. No. What? I just say here, let A stand for e power c. After all, it's still just some unknown constant. And please remember, I said it is fine to stop here also. Or, they're all k's. The reason I did that, what? Don't you like my k's? What's wrong? K, or. What? Okay. K, or, and smiley face.
What did you do here?
Where's here?
And the third line.
Here.
No.
Here.
Before.
Here.
Before the hour.
Here.
No.
Here.
Yes.
I brought the dt up to the right and the c down to the left.
Why?
That's what we did in the last lesson. Come on, guys, get focused now. Now look, the reason I rewrote it like this is because you did these problems in semester 1, question 4 of the exam, where you have to find the a and the k after I give you some information. So for example, I would say, at the beginning, there was one cell. And then, after 15 minutes, there was 2 cells. Remember? And you can put those into this formula to find the a and the k. This is something I will not do since it is from a semester 1, a chapter in skill. But I can tell, if you remember, it's very quick to find the a, because the a will always equal the first number, yeah. So it is only the k that requires some work. So I'll leave that one there. I'll do another one. For fun, I will do number 2 here. By the way, this one here is not on the worksheet, okay? That's just my example I made up. Well, not made up, it is a real example. By the way, this rule is good at the beginning for maybe the first few hours, but of course the petri dish is finite in size, so it's not like the bacteria will keep growing. They'll only grow up to a certain point, okay? So what you can do is you can improve these formulas. You can say the rate of growth of bacteria is proportional to the number of cells in a dish, as long as, and then you can put some limit in place, okay? I think you did something like this in one of your experiments with Colin, where you had like food coloring going into something, or what biology experiments did you do where you put one color into something and it foams up, or enzyme one? Yeah, what did you have to do in that one? You had to heat it up or something, was it? And then you had to measure how much foam. Good. So I suspect for that one you could say something like, if you went on the internet, you would probably find something like the amount of foam that was produced is proportional to the temperature that was applied. So if you double the temperature, maybe you get twice as much foam. Was this right? Yes? To a certain point, yeah. And then if you heat it up too much, you kill your enzyme. Yes, good, yes. Biology, piece of cake. Yeah. Right, so I'm going to do now a chemistry one here, which will be number 2 from the worksheet. Reaction rate. Who can give me the definition of reaction rate? I have it here in the question, but who would know it from chemistry? And bear in mind, Lorraine is a few doors down and she'll be angry at you if you don't know this. She will sense that you're being stupid about chemistry. So reaction rate, what's the definition? Anyone know it?
It's the rate at which reactions form.
Yeah. I don't know exactly how you phrase it in chemistry, but for me to make it sound more mathematical, it's the rate of change of concentration, or whatever word you use, concentration. And what symbol do you use to represent concentration? C? Are you sure it's possibly not this? Yes, which I saw on the board a few days ago. So look, the rule is reaction rate is proportional to concentration. Look, that is a fact, that is a rule, that the reaction rate is proportional to concentration. So now, as being good mathematicians, we'll write this as an equation. So to begin with, what letter are we're using concentration here. What is the definition of reaction rate? So what's rate of change? That is time derivative. It's the rate of change of what? Concentration. And then what? It's proportional to concentration. Fantastic. Now, what's wrong, Finn? Problem? No. So how do I get rid of the proportional here? With a constant. Yeah, with a K. Now, what do I do to solve this? I divide. So on the left, what would I have? 1 over concentration d concentration equals this a went underneath here on the left, divided by a, and then the dt, I bring it up to the right. So what do I have here? K dt. And by the way, like I said, Sarah, if you want to write the a underneath this, yes, okay. If you prefer that, I can do it like that. dA over dA. Yeah, now just be careful. I know it looks a bit, not dA, just A. I know it looks a bit confusing, but really all it is dx over x. Now, but I know it looks a bit weird. Equals K dt. Okay? Yes? So integrate and integrate. What do I get on the left? Log A. And what do I get on the right? T plus C. I use my E on both sides and I get A equals EKT plus C, which I can happily rewrite as A equals a constant, and maybe not to confuse it with this A, I'll give it a different name. I'll call it constant B, e to the power kt. But in fact, you know what? I will call it A, but I'm going to call it A0, because it's going to just be whatever the concentration is at the beginning. So often if you look in chemistry books, you'll see the answer written like this. And remember, it's fine to stop here. This is called the first order reaction rate law. So this tells you that the concentration of A will increase exponentially or possibly decrease exponentially, depending on if the K is a positive or negative number. That is, if it's an increasing or decreasing type of concentration. Now, watch this. You don't need to write this down, but in a different colour here, reaction rate is proportional to concentration squared. This is called the second order reaction rate law, and all I change is put a square here. And it's a different equation to solve. And what about if I told you the third order reaction rate law? So you have these different reaction rate laws, and depending on the substance, you'll use a different law. Okay? So how much of this have you done? Like, I mean, in chemistry, would you have seen this formula? Possibly not, or you have? For real? No fooling? Oh, that's fantastic news. So then have you needed to use log then in chemistry? I know you need to use log base 10 for PHP stuff, yeah? Not PHP, sorry, PH. Sorry, I was thinking of programming language. Okay, so look, this is all about your maths assignment. So I'll read it to you here, I'll give it to you to look at, and we can talk about it too for a moment. Actually, no, I should hand both of these things to you. Let me just stop this here.